So DNA is the only biomolecule which can be repaired and made error-free. So should we do DNA repair? Because there are some changes, alterations that can occur to the DNA. For example, there can be single base pair changes, or there can be two base pair changes. Example, UV light induced thymidine dimers. There can be chain breaks or cross linkages, all can be formed. Okay, so there are different methods of DNA repair based on what is the alteration that is occurred. So, but the general principle of all these methods of DNA repair remains the same. Okay, first we have to identify the daughter strand. Okay, so we all know, as a result of replication, we will each daughter's DNA will be having one parent strand and a daughter strand. Okay, so if errors occur, if the above mentioned errors occur, they would only occur in the daughter strands. Okay, so first we have to identify the daughter strand in that DNA, then we have to identify the area or that portion which is defected, then we have to cut that defected area with the help of endonucleases. We have to seal that area after polymerizing by DNA polymerase. We have to seal that nick by DNA ligase. So there are, as I have already mentioned, there are different methods of DNA repair. Okay, so base excision repair is the first method we are going to discuss. Okay, so what was the change that occurred here? That is, a single base change occurred. For example, as given in the example here, there was a spontaneous deamination caused due to a mutation, due to which a cytosine unit got deaminated and NH3 was removed and it became uracil, as seen in the figure here. Okay, so it became uracil. So now we have to correct it back into cytosine. So what are the steps? We have already told. First, we have to cut that site. That was the first step. After identification of the defect, we have to cut that site with the help of endonuclease. So before just giving the endonuclease, here we have an additional step of removing that uracil molecule by using specific N-glucosylase, because we all know the bond that exists between a nitrogenous base and a ribose sugar is N-glycosidic bond. So the enzyme which cuts it is known as N-glycosylase, specific N-glycosylase. So it cuts that uracil from there. So as a result, a apurinic or an apyrimidic site is formed, as it is marked by a cross mark in this diagram. Okay, a apurinic or an apyrimidic site is formed. Okay, now then as in our general principle, an endonuclease, an apurinic or an apyrimidic endonuclease will act, and that will break the 3' to 5' phosphodiester bonds just prior to the cut uracil end. Okay, so it is cut there. The main parent strand, the base strand of 3' to 5' phosphodiester bond is now cut there. Now what will happen? Now what is remaining there? The nitrogenous base is removed. There is only a phosphate group and a sugar there. So now that has also to be removed, so that we can replace it with a very new cytosine which was originally present there. Okay, so first we have to remove that sugar and that phosphate group. So what will be the enzyme's name? In the case of a DNA, the sugar present is deoxyribose. So deoxyribose phosphatelase enzyme will cut that remaining sugar and phosphate from that site. So now we got a complete nick over there. Now the DNA polymerase will come and seal that nick, and that will be completely joined by the DNA ligase. Okay, so as you can see here, while we have to seal it with a cytosine unit, because in the opposite strand, complementary strand is guanine, so here it should come as cytosine. Okay, so a DCTP molecule has changed to PPI, and a DCMP, that is cytidine monophosphate, deoxycytidine monophosphate, is added over there, and this is what we get at last, and this is exactly the same as our original parent strand. So the DNA is now repaired. Now the clinical condition which can occur due to defects in base excision repair is MUTYH associated polypops. So that was the first method of DNA repair called base excision repair. Now we have two more methods which we will deal in the next two videos. Don't forget to watch them. Thank you.